Hello and welcome to another demo on Azure Kubernetes services. Many of you have been watching my videos for quite some time, and I appreciate your feedback and support. Please note that your feedback, your support is the only encouragement that I have to create these videos. I hope you guys like it. Today demo is going to be a very interesting demo which will be trying to see why we should integrate Azure Kubernetes services with Azure Active Directory, and by doing that how can we leverage Azure Kubernetes services RBAC, and also very interesting is to see whether can we use the managed identities with parts to access different Azure resources. So that's the scope of the today's presentation. And without any further ado, let's just walk into the presentation. I'll give you a brief introduction of what business challenges, what technical challenges we are trying to resolve, and then we will immediately jump onto a demo, right? So with that, so the first question is that why should we even do the Azure Kubernetes services integration with Azure Active Directory? Now, at a very high level, we have talked about this situation in my other presentations on my YouTube videos, which is around Azure Kubernetes Services design consideration. And if you have not watched that, I would encourage you to watch it. I'm sure you will find some valuable information there. So one of the key elements that I think we all have to understand, and for lack of better words here, let's just say when an organization chooses a route to use Azure Kubernetes services, which we all know is a hot potatoes these days, there are reasons for that. And one of the reasons is that instead of a traditional data center VM approach, now we're going to leverage Kubernetes services for providing a modern application platform, right? And that's the drive behind it. And many people really don't realize it, and they jump the guns and they say, hey, AKS is cool, let's just do it, without understanding the reasoning behind why should you adopt to Kubernetes at the first place. Now, for the lack of better words, I would say this way, that would probably explain you why we should do the Azure AD integration here, is that consider Azure Kubernetes services as one big data center, right? Instead of just thinking about some few VMs here, because in one data center we have got different teams operating, different teams functioning differently with proper security controls, and we can mimic that into an Azure Kubernetes services cluster by having multiple different resources, multiple different services, and multiple teams managing that. Now, having said that, it is easy saying than doing, because as all of us know that Kubernetes is using these orchestration layer on the containers which are running on these cluster nodes, but pretty much they are leveraging the shared OS kernel, right? So now, and I would encourage you to read my or view my other articles or other videos that I have on YouTube for introduction to Azure Kubernetes services, which would probably explain you my thought process better. Now, having said that, how do you segregate that, and how do you achieve or accomplish the business goal that we are talking about, that hey, multiple teams can access different resources differently within one AKS cluster, right? Because all of them are using the shared resources, and by default everything can talk to everything else. So there is an isolation approach and isolation strategy around Azure Kubernetes services, and it has been detailed in the other video that I have talked about. But there are multiple ways of accomplishing that kind of isolation, and depending on your business, security, compliance, governance needs, you might have to choose one of them. And one of them is the physical isolation, where you segregate physically your clusters from each other, and that may be a good option for some of the customers. The second is a logical isolation, and logical isolation is what we are talking here. Logical isolation is achieved through namespaces, right? You can create Azure Kubernetes services namespaces, and once you have namespaces, you can organize your resources within those namespaces, and you are isolating resources into multiple namespaces. Having said that, by default, every single namespace is available to a cluster admin, and is also accessible from the networking perspective. So how do we get that delineation of roles and responsibility here is done through Azure Active Directory integration. So basically, next slide would also show you that what I mean about Azure RBAC. And in that scenario, you can achieve your logical isolation from three different factors. One is organizing your resources in the namespace, which is a first step to the logical isolation. And second is do the network isolation through the network policies. Hopefully, I would give you another presentation on that one day, maybe soon. And thirdly, that you define a different AKS RBAC on different namespaces. So one group manages one namespace, another group manages another resource, another namespace, so that you achieve the total segregation and delineation of roles and responsibility and who can access what within the cluster. And that goes back into the initial thought of thinking and leveraging AKS as your customized data center for you for hosting your modern app, right? And that's the big promise that we are bringing in here. And it's relatively simpler and easier to do that, but there are certain caveats that you guys have to understand. Many of you may already know that, but those who don't know it, just one thing that keep in mind that Azure Kubernetes services are by default not integrated to Azure Active Directory. So if you create a AKS cluster without considering the Azure AD integration, that's not going to happen, right? So you need to do some additional effort to integrate Azure Kubernetes services cluster with Azure Active Directory, and importantly, this has to be done while you are creating the AKS cluster, right? It cannot be enabled afterward. This is very important. Please keep it, because if you create a regular cluster without realizing whether you have used all the required parameters into your command line or CLI, it's not going to integrate with the Azure Active Directory, and you would have to destroy it and recreate it. So instead of going that route, let's make the cluster from the day one as an Azure Active Directory integrated. I think that should be a rule of thumb for everyone, and I just recommend you guys that whenever you create a AKS cluster, keep in mind that you would be creating an AKS cluster with Azure AD integration. From the architecture perspective, it's pretty straightforward, right? So you can, the engineering user creates a cluster with the Active Directory integration component of it, and in the center you will see the cluster master, the API server, which can communicate with Azure Active Directory because of the integration that you have done, and then credentials are verified against Azure Active Directory. Based on the token, the resources are allowed within the AKS cluster, right? So it's straightforward. Now, when you do that, it is very, very important that you keep in mind that not only you would be doing the Active Directory integration here, but if we want to use the manage identity, which we're going to talk a little later here, you also have to enable the manage identity right during the AKS cluster creation. That is again an optional component, and you cannot enable it afterward, right? So both of the ingredients has to be considered. And by the way, the pod manage identity, that is our next topic, would not be possible if you have not configured or if you have not integrated your Kubernetes cluster with Azure Active Directory, right? I think this makes it absolutely clear, the point that I'm trying to make, and the next slide probably would be a repetition of what I just said, but let's see. So what is an AKS RBAC will do for you? As I mentioned earlier, the AKS role-based access control will allow you to do the logical isolation that I mentioned earlier, right? On top of it, with this role-based access control, as I was referring earlier, the different teams can access different resources, and that is possible based on Azure Active Directory users or group IDs, and that's very simple to do that, right? It looks pretty awesome to me I look from the security and the AKS design consideration perspective, and I think all of us should look into. Most of you might already be doing it, but I have seen emails and requests on my YouTube that to come out with this video, and that's the reason this video is for you guys. Now, Manage identity would be the another part of our demo today, and I just want to make sure that we understand that what is the business challenge that we are trying to address with this pod manage identities, right? So before we actually start talking about Azure manage identities, let's just make sure that we understand why it is so important. So from security perspective, many of you may agree with me that one of the biggest challenge from security in terms of identities are the service account. Now all of us forget about cloud for the time being. In Windows world, the service accounts are regularly used and often used in multiple places depending on the organization. These service accounts passwords are never changed, because if you change the password in Active Directory for that account, you have to change the password at the service, and if there are multiple services and you forgot to do that, then it breaks the services. So by and large, I think most of you would agree with me that the service accounts that you create in general are very vulnerable because their password never change, and the hackers are looking for these service accounts, and sometimes these service accounts also acts like a honey token accounts, and that enhances the vulnerability in terms of identity management, especially with the service account, because password never changes, right? Now Microsoft has come with something called as group managed identities since Windows Server 2012, which takes care of that. Basically what it does at the high level is that you create that manage identities, and the password management is done by Microsoft, right, behind the scene by Active Directory. So by and large, you might already be knowing that any Active Directory joined machine password is automatically changed every 90 days, right? So that's the default, and that's how they remain trusted. If that doesn't change or that gets into messed up, then the particular machine loses the trust with the Active Directory and cannot authenticate any further. Now, because manage identities from the group manage identity or GMA in Windows have that ability that all the password management is now with Microsoft, you don't have to worry about recycling the password every 90 days. It is automatically being done for you. So keeping that mindset here, think about when we are using services in Azure, it is the same scenario, right? Because if that service identity is the regular service identity, then you need to keep and remember the password, and you're not going to change the password, and you become a victim of hackers, especially from the service identities perspective. Even if you use the service principal name, the SPNs there, that password you're not changing that password, and if that gets hacked, then you have the same issue. By using the manage identity, what happens is that you never know what the password is. You never need to know what the password is, and all these identities are managed by Azure Active Directory. And that makes it very secure, and that makes it very effective way of allowing accessing the resources within the Azure. And that's the level, that's what we are trying to do in this demo today, that instead of using a service account or a regular service principal name, we would ensure that we can use the pod manage identity to access different Azure resources. And your Azure AKS resources may be accessing a key vault for keeping your secrets, pulling your secrets out of the key vault. They may be access storage accounts. They can access any PaaS services that you like. As long as that PaaS service is Azure Active Directory integrated, you should be fine, right? Alternatively, that's a little bit more complex. If that particular resource is not Azure Active Directory integrated, and you still want to access those resources through manage identities, you can keep their credentials into the key vault, and you can access that resource through manage identities by accessing that credentials from the key vault and passing it to the resource. So not only you could access resources that are Azure Active Directory integrated, but also you have the ability to use manage identities for those that are not Azure Active Directory integrated, and that has a separate identities that you can store it in the key vault and procure it from there. So quite an intriguing solution in my viewpoint, and I don't think that many organizations have taken the advantage of this default offering by Microsoft. Uh, so we're going to look into today, and we're going to do the demo part of how you can leverage the managed identities. And I'll go up to the key vault and show you that what are the different tasks, steps that you need to do. It's not that simple. Documentation is not that great as of now. So you have to burn your time and figure it out with the hit and trial kind of stuff, which I think this video would eliminate that hit and trial for you, and you can save some time if you watch this video till the end of the presentation. Now, I'm not going to go and read all that for you, but basically there are two different types of managed identities. One is a system managed identity and one is a user assigned managed identity. Our demo today would leverage the user assigned managed identity. You can see the difference in the table that I have given you. Pretty straightforward, and the process is very simple, right? So within the Azure Resource Manager, you create either a system managed identity or a user managed identity. System managed identities could be created for a variety of Azure resources. For an example, you can create for Azure Virtual Machine, you can create for web app services. You've got plenty of stuff. I have a whole other documentation. Maybe sometime later I would go deep dive into just the managed identities demo, but for today's demo, so the managed identities are created to the resource Azure Resource Manager. It creates a kind of a service principal in Azure Active Directory. Remember that we are not worried about any longer a password here, because that's the biggest value proposition. And once that is created in Azure Active Directory, it updates. This is the interesting part, right? Which is not happening with a regular service principal name. This is updating the Azure Instance Metadata Services, which is IMDS. And now that service would allow you to get the access tokens to access different resources, right? This IMDS is very important, and it is accessible to this URL, which is 169.254, 169.254. This is standard. You will get the OR token, and I'll show you in my demo, and it will make it a little bit more clearer when you see it in action, right? And that's the whole chronology here, right? You don't have to go anywhere. You don't even have to go to the Active Directory, Azure Active Directory. You can access these resources through Azure Instance Metadata Service, which is what is a critical element, centralized piece of this architecture, and it helps us resolving our challenges of regular identities with regular passwords, right? So that's the big picture today, folks. I will just dive into the demo right away. We'll go step by step, and I would also keep all the steps into a separate PDF or a document and attach it into the description part. So you don't have to actually note all the steps and note all the CLI commands. It should be available to you. Just watch the video and enjoy it. Thank you. And let's get into the demo right away. So, all right, so we are ready to deploy this new AKS cluster with the Azure Active Directory integration, as well as with enabling the managed identity. It is pretty straightforward once we have followed all of our steps here. So we need a network resource group for the VNet, which is what we have here. We have a region, we have the VNet for the AKS cluster, we have the subnet for AKS cluster. This is our subscription. This is the service principal that I have already created that would be used for the deployment of the AKS cluster, and you need to have it. Without that, you would not be able to create the cluster. Then we have the resource group for the actual AKS cluster, which is the same as our VNet. It could be different for you. Our cluster name for this example is Apple AKS MSI. This command would get the VNet ID. This command would get the subnet ID. And this is important because unless you assign the contributor role to this service principal that we are using for AKS, it may not be able to provision the right network resources for you for AKS cluster. So don't forget this step to allow and configure the RBAC role, contributor role on the VNet. This is important. And then we would need the Azure Active Directory server application, Azure Active Directory client, Azure Active Directory tenant, and the secret for the server too. Now, what I have done here is, instead of wasting your time, I think I can show you an article that I used it um, to create these applications. Let me walk you through. So this is the URL for creating those applications in Azure. And you follow this to create the required client and server application here. Very straightforward. I can show you in my Active Directory here. So if I go here, I just did it. So I have got this AD server, a client here, and I have the service principal for AKS. So these three are the prerequisites to configure your and create your cluster with Azure Active Directory integration, right? So if you go back to our command here, so this is what it is, and once you do that, you run this command, and that should create a Azure Active Directory integrated and manage identity enabled AKS cluster, right? So we have saying very simple command AKS create resource for the cluster, the cluster name, the Kubernetes version, the load balancer here. We are talking node count here. This is lab, so I'm just doing 2. SSH key. We are using the advanced networking, which is CNI, not the kubenet. There is a difference between basic networking and advanced networking. I don't think I would have time to detail it here because then the video becomes too long. So understand that basic networking is most of the organizations would not use basic networking for their production workload, just for the simple fact that the basic networking doesn't allow you the network policies. There are other caveats with basic networking. So you would be most likely using advanced networking, which is what we are using here. This is the service CIDR for all the services, virtual services that would be created in the AKS cluster, the DNS server for that, and Docker bridge services, which is important. We need to have the VNet subnet. This is what we are capturing as a variable here. We are also getting the subnet ID, which is again the variable that we are procuring earlier. Service principal, which is what we are getting from here. We are getting the client secret here. That is, you are also getting a variable. Then this is where the Active Directory integration piece comes into picture, right? So AED server app ID, which is what I captured here. I somehow had problem with the Unix command for this variable, so I just put the actual value. In your regular PowerShell or as Easy CLI, you can just put the variables here that we have defined here. And then at the end, you would also see that we are enabling the network policy is Calico, not Microsoft Azure policy, which is the other option. Calico policy has some advantages over Azure policy, and my customer wants a cloud agnostic solution, so that's why I prefer to go with Calico. And then last but not the least, which is important, we are also enabling the manage identity, which would be part of our next demo, or next part of the demo. So once I do that, I also have this is what I was talking about, folks. I have deployed an Ubuntu terminal on my Windows 10 machine. I'm not a Unix person. I just started it yesterday, so I'm running it through some hiccups. That's why I'm still playing with Unix command. I copied the syntax from here, and I actually deployed the cluster by copying and pasting here, and it has actually completed the cluster deployment. Perfect, right? So we are good, and we should be able to see the cluster in our resource group here. And in sandbox, we have our cluster, we have our VNet, and we should have created all the resources in MC resource group, which Microsoft automatically provisions. We have the skill set, we have the agent pool, all good stuff here, right? So okay, that's pretty cool. I'm surprised that I have not seen the load balancer created here. That's interesting. Wow, that's actually cool. All right. Now we're gonna try to do the RBAC portion of it, and I'm just gonna create the required command line, and I'll come back with you. All right, let's first check whether the cluster that we have created is Azure RBAC enabled or not. And it's very simple. If I run this command here, it should give me the true or false whether this is RBAC enabled or not. So it didn't find it because I didn't have the variables here. So 1 second, I just pick it up the variables here. And as you can see here, this has been enabled, right? So we are ready to configure our RBAC. And the first thing that we need to do at the RBAC, as I discussed earlier, that we need to have some security groups, some users added to that, and then we'll create some namespaces, we'll create some roles, we'll bind them, and then we'll see how does that actually take place, right? So the first step is to create the groups, and I'm going to create these 3 groups. Let me just do this here. And one group is called as an app dev, second group is ops SRE, and the third one is the AKS cluster administrator. So let's do that. Oops, and copy. So these 3 groups are created. Now we need to find the resource ID of the AKS that we're going to use down the road for assigning. So we're going to get the resource ID for the AKS cluster that we have created. And if I run this command, that is resource group $AKS-RG, I'm making sure that fine and the cluster name is fine. Okay, that should give us the resource group ID. Oh, sorry, AKS cluster resource ID. Okay, we got it. Now we're going to create the role assignment, right? So we're going to create role 2 of them. The third group that we created we will use later for the overall cluster admin part. That will come later, but for these 2 groups that we created, app dev and offshore, we are going to assign them Azure Kubernetes service cluster role, right, on this one. That's the RBAC part. So we're going back here, and then we are going to enable those RBAC roles. So if you see that we are giving them Azure Kubernetes services cluster user role on that cluster itself. I hope you could actually see in the GUI here too, in the GUI I mean. So if I see app dev here, and let's see this is what we are expecting. So the cluster should be here, and this is Azure RBAC. This is not AKS RBAC, right? Understand that there's 2 different things. This is the Azure RBAC. And if I say here app dev, the resource group that we just created, the security group that we created, and it has been given this credentials, right? And Azure Kubernetes services cluster role. So that's exactly what we did for both the groups here. And now we're gonna go back here, and we're going to create 2 users for each of these groups to see how the RBAC works. One is AKS dev and second is AKS RE. So we're going to create these 2 users now, and that we can do again through CLI. Okay, I don't think it like the password here. Oh, I don't have the space here, so apologies. So those two users are now created. Now we're going to add them to the appropriate members, the groups. So obviously app dev goes into the app dev group, and then second one goes into the apps SRE group. So we are giving them the proper group membership. Okay, making sure I don't have the problem anymore. You could actually do that in the GUI, or you could also have that groups already provisioned in your environment. So I'm just, for this experimentation sake, we are doing that. Now, next step is to create the required two different namespaces. The whole objective here is that we will have one dev namespace, which we would give the privileges and the rights, RBAC rights, to the apps dev group, and the second namespace that we will create, as we discussed earlier, would be SRE, where we would give ops SRE group the privileges to manage those resources, right? That's the RBAC model that we are working on. So first thing is that I need to get the credentials for the AKS cluster, and we're going to go and execute this command so that I am in the cluster. Cool. And now we're going to create these two namespaces. One is dev and one is SRE. So let's do that. And then SRE is created. Now the next is that we need to create a role for the dev, and then we will create a role for RBAC role for the SRE namespace. So how we do that is we're going to apply a file called as a role dev namespace file. So if I have it here, this is my file, and see here the namespace is dev, and we are giving the dev user full access. It will start talking to Active Directory, right? That's what the role is all about. Once we create the role, then we'll create a role binding and we'll assign it, right? So that's what it is. So in order to do that, I have to execute that command, but I'm not in the right directory where my files are. Oh no, I shouldn't be doing it because this is Ubuntu. So I have to copy that file first, cp mount c ubuntu slash, what's the file name? This is what where I'm copying my files from my local Windows 10 machine to the Ubuntu console. That's what I'm trying to do here. So this should be the role for dev namespace. I guess that's what we are running. So rename it, copy it, and oops. Let me copy it so that I don't waste your time, and I come back here in a second. Alright, so I have copied all the files here that I would be needing to create the roles and the role binding. One role for dev, one role for SRE namespace, one role binding for dev, one role binding for SRE. Right, so we can execute these commands now. So first is that we're going to create a role for dev namespace. And as we have the files there, so it should be pretty quick. Perfect. Now we're going to create the we're going to get the resource ID for before we apply the role binding, because we need to assign the group here. So we get the resource ID, the group resource ID for the group app dev, which we have to assign to this bind with this particular role. So we're going to go here and get the group ID. Okay, and there's our group ID, group object ID which is what I need to update the YAML file accordingly. So rule binding dev, there's my dev, and I need to replace this here. Control V, save it, and then I should also do that at the same time for the second group so that I can copy that file. Okay, so new, then I should do this role binding for this guy for SRE, ops SRE group, and I will get that identity group ID. Okay, got this one too, so I have both the files fixed now. And role binding, I have to change it here, save it, and unfortunately, because this is in terminal, I have to rerun the command to copy the files again. So role binding SRE, we copied, role binding dev. Okay, so we're good. Hopefully here we copied back the files with the group ID there. Okay, so now we can run the commands here. So we created the roles, we got the resource ID for this. Now role binding, we have to apply the role binding for appdev group. So kubectl apply. Okay, and then we would do this for the next one too. So we did that. We created the role here already, I guess. Did we? Okay. So now we're going to create the role for the SRE group, SRE namespace. Okay, and then we're gonna go to the role binding here, which already fixed it here for SRE, and that should complete this configuration. Then we can actually test it. Role binding SRE namespace YAML. Perfect. So that completes the whole RBAC portion of this. Now we have to test whether that really works or not, and I shall be back with you in a second. All right, so I'm logged on my Ubuntu terminal, and I have already logged into the AZ Azure. I just want to make sure that I can connect to the right subscription. So we're going to do this here, and then we're going to start testing. So go here, make sure that I'm connected to the right subscription. And the first thing that I need to do is that I need to go and as far as what documentation is concerned, when we go to the test mode, we would be first authenticating or getting the credentials, not as an admin, right? That's the point. So let's go here, test right here. So override the existing, and that should prompt us for credentials and enforce the RBAC testing, right? So we are gonna do here, okay, I do not have the AKS RG, so I'm just gonna do manually here. All right. So now if I try to create a pod here in the namespace dev, we will try to do that, and it should ask me to authenticate, and that would be our good test. So before I do that, let me open another browser and new window, and we'll come back here in a second. Okay, and then we're going to try to create this part for NGINX. That's our next command. So I'm going to run this command. Oh, not this one, right? So I have to sign in here. Okay, namespace dev. And obviously it's asking me to authenticate. The RBAC should now come into picture, and hopefully if I go here, it should ask me for that code here, and the code I have to capture from here. Gonna ask me to sign in, and I have to sign in here as an app dev guy. So do I have it here? AKS dev, right? So that's the account that we gave the rights on this namespace, and sign in. Oops, why should it go there? I think so. I'm gonna try to log in here as that account that we created. Obviously, password. And that should be enough to get into there, and my pod has been created. So now interestingly, I can check whether my pod has been created. kubectl get pod namespace dev. Perfect, right? So we can prove that because of the rights that we have given to RBAC, we can do that. Let's see if it can try to do something beyond this namespace. And I'm sure it's not going to let me do that because we have not given him the right. So if I do this, it should error out, right? Cannot, it is hidden for us because I don't have rights on any other thing. Even if I try to create a in the SRE, I think it should also error out. Let's try to do that. Try to create this NGINX in SRE namespace. And obviously that's not going to work, right? So now we have proven that with the RBAC rule, this particular account, AKS dev account, has the rights to do and manage the resources in the dev namespace, but he can't do anything else. We can also try to do the same thing for the SRE group, and let's make sure I have the account created here. We will need to log in here. Control V. I believe it was AKS SRE. All right, so we're going to try this in the SRE resource group with a different account, and I'm going to get the credentials back again, the fresh credentials. So oh the variable, so let's go back here. Okay, so we are logged in back here. We're going to try to create a same nginx pod in the SRE namespace now, and I am pretty sure that we should be able to do that because it will ask me to get to that account, log in here, the same thing like I did, but this time we will log in with SRE account. And going back here, you just get here, get the code, and this time we have to log in with the other account. And password obviously. And that should do the job. So it has already created the pod, and now we can see here, going back to the console, kubectl get pods and HRE. We got it. I'm sure if he does it for dev, he should fail it. Yep, right, that proves the point of our RBAC model is working. Now we need to go and how cool it is, right? So now we have proven that you could use Azure Kubernetes Services RBAC very effectively, and you could manage the AKS cluster by different teams for different resources. So that's pretty cool in my viewpoint. I hope you would like it. Next part of the demonstration is the manage identities for the pods. That's a little bit more complicated, and because the video is getting longer, so I have already executed the command and we will see it in action in a few seconds, right? So let's go back to our notes, and when we go to the pod manage identity, the first command that we need to run here is to run this command. And what this command would what this command will do it is that it will bring a new API which is called as, if I can show you here, AD pod identity. That's the API it will add into the section, and it will also create an MIC containers and deployment here. So let me show you what it did. So if I say just here kubectl get pod, I should log in here as the regular user first. This is not going to let me do that because I'm logged in here as a okay, so kubectl, and it's going to create in the default pods here, get pods. Come on. So what I was talking about, that these pods, which is what being used by the pods identity management, anytime you assign a new identity, it is going to report it here. So if you see here, if I go back here, kubectl logs. So it will show you that how many identities have been assigned. As soon as something changes, new pod comes in, new pod, the identity is assigned, it will show up here, right? So that's one thing. And so that's our first command. And once we ran that, we also see here the version here. So the important thing that I was talking about by running this particular command is that it's gonna bring this API, and unless you have this API you can't go any further. So it's a very important command. Once again, that the command that we were talking about was the part right here, right? So this is the command that did that. Once you ran this command, it brought that API which is going to be used for pod's identity, and then it also created an MIC managed identity containers inside the AKS cluster, right, which we would be leveraging further. Then what we did is we created a Azure identity which is called as AKS user. This is just a user assigned identity. So if you go back into our resource group here, you should see it here, and that's the user, AKS user. That's what we did in that command. So we created that, and it will, because we are asking the output into a JSON, it will give you this output which we will use the client ID in the next command. So next command is apply AAD pod identity lab.yaml, and let's bring this file here. So that identity that you have here, the client ID, you have to replace it here, and you have to replace the username here, making sure that you also make sure that the resource ID is also changed in your YAML file. These three things, right? Make sure your identity is the same, that you can pull it from here as well. Actually, if you go back into the command, this is right here, AKS user, and then you have the client identity here, and you also need to get the whole path for this, which is the subscription ID here, right from here, right? All these three things you will grab it from here, change the YAML file, and once you change the YAML file, you will create an identity, right? An AAD pod identity lab.yaml. We apply it. We can check it if you want. So if I say here, going back to the YAML file, which was the YAML file was AAD pod identity lab right here, right? So this is Azure identity, and we can query, we can find it. So if I go back into this and say kubectl get, instead of running this command, I can find it. So that AKS user is right here, the YAML file. You can also go here, kubectl oops, and AKS user, and you will see if you make a mistake in this small thing and miss a step, then you're gonna burn a lot of hours. So be very careful with this. You will make sure that this is the same identity. All right, so we are good here. The next command that we need to do here is to apply the binding here, and the binding, you create a YAML file. The YAML file is interesting. So if we go here to add, this is a file, you have to pick up a selector here. This selector you would be used by the pods. So label, you have to create a pod label with the value should be MSIE enabled. We'll see in a moment again. And unless we do that, you would not be able to bind the pod. So, and if the pod doesn't bind, this is a common error. Making sure that you have the same identity name here that you have in the other file, and you pick up, you can select any selector that you like, but I just used MSIE enable, and we'll see how it works, right? So then we apply this file, which is what I already applied, right? So if you go ADI, and we can see it here quickly. So if I go back into this and say, hey, kubectl get, and that's the, we already did that. And if you want to see the detail, so we can say here describe. So instead of doing a hit and trial there while you guys are with me, I just completed these tasks and I can show you here, right? So you see here, this selector is MSI enabled, user is AK user. Perfect. Now once I have done that, the next thing that we need to do, so our binding is ready. Now we also need to make sure that we provide the managed identity that we got, the resource client identity, and we gave that the RBAC roles on the resource group that Microsoft created, as well as the resource group being used by VNet. And these are the commands that I already ran, right? So interestingly, you need to understand this, because I think it's difficult. If I run this command here, so what we are querying here, we are trying to get the managed identity for this Atul AKS MSI, right? So I'll show you this quickly. So if I run this command here, and this is the managed identity. Why and how it got created, you should ask this question, right? So if you go back, and you will be surprised at how effective it is. This is why, because when you created the cluster and you use the option as enable manage identity, that's how it creates that identity for your VM scale set, right? So if I go to the enterprise applications and I select all here and I select for this grid, you will be pleasantly surprised. So this is what was created as a part of our command that we ran during the AKS cluster. And again, just to remind you that if you do not do that in the AKS creation process, you cannot update it, you cannot do it again. You will have to redeploy the cluster again. And that's why it is better to do it now during the creation than redo the whole cluster. So that's what it is, right? So we did that. Now I have already ran all these required roles. This is also very important. If you miss it, then you are going to run into a problem, right? So I ran this tool, all these commands here, and then what we did here, that I installed these applications, two applications here. One is AKS Hello. Let me just show you the pods here, and I created the default namespace. So if I go here, kubectl get pods, you see here these are the one that I created. Now the trick here to assign the managed identity, that this label should match with your selector. So if I go here and do this, right? So if you see here, the first pod here, I didn't do for all of them. It has a binding. It has a label called as a AAD pod ID binding. It has to have this label, which should be, the value should be equal to what you have created as a selector, right? And I did that. As a result, now this pod has binded with the user assigned identity that we have created, and that's the trick. Somehow, if that doesn't work, then we're going to run into trouble, right? So this is very important to understand, folks. Now what we already did, we did the pod right here, the command that I ran here, so that the pod is enabled with that Azure identity binding. That's the thing that we were seeing here, right? But this should be this. I think I have a wrong command here. I captured it wrong. Azure identity. This should be this command, because if you use this, you're gonna run into a problem, right? So this is the value, this is the label, this is the value. Once you do that, now we can check before you do that, right? So we created this Azure identity that I already checked it for you. We checked the Azure identity binding that we checked it for you. Now this is the crust of the right here. This should show you that which pods have been assigned the manage identity, right? So if I do this here, see here, and that means we have this pod that has been assigned the manage identity, right? So if you go up here, the status assigned kind pod blah blah blah, node name is our node where the pod is running, this is our pod, right? And that's where the identity is assigned. And if you scroll it down, you will also see the identity value here, specs, and what's the other identity that is assigned to this pod is AKS user, right? And folks, what I was mentioning earlier, that these things you will not find it in any blog. This is seeing is believing, and unless you run into the problem and you waste some time, you will not get here. So this is, in my viewpoint, this is making this will make your deployment easier, because now you know what you're looking for. So once I did that, I am good. My pod has a binding here. Now the next task is that I need to get the keys, right? So I should first do the exec into that pod, and then we can get the vault access token. So going back here, let's just get the pods here first, and then we can get bash into the pod IT, and this is the pod where I have the binding manage identity, and there's no space, so I can just do the bash here. Voila. And now we can check whether our manage identity works or not. So if I do that, I also ran these two commands, folks. If you see apt update and apt install JQ, because I finally need to get a token into a variable, and the JQ would allow me to get the variable, right? So let's check this. Okay, so let's just see whether we can get the access token from the key vault, and you can do for storage and other stuff too similarly, right? So I'm just giving you one example here, and that's my token, right? What I also want to do programmatically, that I don't want to have this access token, and I only want to capture this piece, which is my actual access token, which you guys are already familiar with, which I would run with the next command, which is where I'm going to get the token as a variable, and my JQ install would help me do that. So if I do this now here, so I got the token, right? So if I say here echo $token, I have my token, right? Now the only thing is that whatever I need to do in the key vault, whether I need to get or I need to post a secret, whatever you need to do. Let's see, I have a secret here which is called as an AKS. Let me show you quickly. This is my private vault. So I'm going to go back here to show you, and make sure that there is one more command that I forgot to write it here, but you need to do that. You can do it manually. So if I go to the source groups and a sandbox, sorry, and then I have this private vault, right? Private one vault, and I have a secret here called as AKS. This is the value we are trying to get of the secret, right? Now you also have to assign your manage identity that you're using, like AKS user, the permissions here, the access policy, which I already did that. Please do not forget to do that. You can do it from CLI, or you could do it in the GUI, however you prefer to do that. So my user has access to this vault, and as a result I can get the value, which is what is the whole idea behind it, right? So now we're going to get the actual value of this secret, and once I prove you that, that means our today's presentation is over. And right here the value, right? It got the value of that token. Very simple, very easy. And that explains you the power of this manage identities. Obviously, once you get this access token, you can get access token for other services too, which are running in Azure storage or something else that your AKS needs to access to. and that's how you don't expose your user regular SPN or regular service identity, and make your deployment way more secure than without using the managed identity. I hope, guys, it makes sense. Thank you for your time. Please keep sending your feedback as always. And there are those folks who are going to watch this video for the first time. There are a lot of other videos on my YouTube channel. So if you search it, you might find something interesting that you're working on. I keep posting these videos quite often. This video was I posted after almost 4 or 5 months. I have been very busy with one complex project, but I'm glad I did that. Thank you again. Have your best of your time and enjoy. Bye-bye.